All right, in this video, we're going to be talking about slope fields. So the idea of slope fields is they are a graphical representation of all the possible things that a derivative could spit out. So a differential equation could spit out. If we get a slope of 0, we just make a horizontal line. If it's undefined, we make it vertical. If we end up getting a slope, we kind of try to approximate it. But for the most part, all they really care about is it kind of slanty downy or is it kind of slanty uppy? When you make your owns. So if I wanted to sketch a slope field for this differential equation, you can see that it really only matters what the x values are. So if I find one of those x values as I move up, all of the y values above it should have that same value. So while it seems like there's a lot of points to worry about, I really only have to worry about the ones between 1 and 4. So let's just start with 0 because that's easy. So if my x is 0, then my y prime, and it really only matters like, is it 0 or is it positive or is it negative? So when x is 0, I'd have 0 minus 0. So y prime is just going to be 0. So that means right here we have a whole bunch of horizontal tangent lines. That's what a derivative is. It is the slope of the tangent line. So it's trying to represent what's happening at that single instant. If I do 1, then I would get, let's see, 1/3 minus a half. So that is negative. 1/3 minus a half. No, a third is less than a half. So then that's negative. So here I want, so just got a negative value. So here I want my slopes to go down for all of these points. So I have a whole bunch going down. If I do 2, so that'll be 4/3 minus 1. So that'll be positive. So now, so this should be positive. So now all my lines are going to go up. Whoop, 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 whoop. Like that. Oh, those last two are bad. My elbow moved. Burp, burp, work. Like that. Next, I'm going to do 3. So let's see. If I put 3 into these X spots, I'd have, let's see, that's 9 divided by 3. So that's 3 minus 3/2. That's still positive. Okay, so these are still going up. Boop, 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 boop. So these are, and notice, because it doesn't matter what the y value is, I'm still going to have a positive value. It doesn't even change what I get for the differential equation because there's no y. If I do 4, that's 16/3 minus 16/3. That's like 5 minus 2. So that's still positive. So these are all still going up. If I was precise, I could probably make them more pointy uppy, but I don't really need to do that. I got better things to do. If I do -1, let's see. So -1 in my little table here, that will be 1/3, then plus 1/2. Okay, so that's going to be positive. So these will be slanty uppy, slanty uppy. If I do -2, in fact, I'm just going to jump here till when I'm done. Yeah, here we go. Okay. So it turns out that pretty much everything was positive. The only one that spit out that negative was that one. Everybody else did a positive thing. So now I want to do this. I want to use this slope field to sketch the solution that passes through the point 1, 1. So here is the point 1, 1. Maybe I'll use black. That'll maybe stick out pretty well. So if that was my point 1, 1, I want to make sure that I follow all of these tangent slopes in order to do the thing that goes through that point. So right here, I've got a horizontal tangent line. And so I'm increasing and then decreasing. So that should be a maximum. I've got a whole bunch of positive slopes, then a negative slope. So I want to have a maximum right here. And then, sure, I'm going down as I go across, but really I am increasing as I move in this direction. Then there is some horizontal tangent line that's happening somewhere between 1 and 2. I didn't put it in my slope field, but I do know that it exists because after that point, it does start increasing. So after this point, we then start going up afterwards. And so there is our solution curve that would be showing up if we went through the point 1, 1. And all we're doing is we're just kind of like following those lines and kind of just drawing over them, kind of like playing connect the dots, but with tangent lines instead of dots. We want to discuss the graph of the solution as it approaches infinity. So as we improve, as um, as x approaches infinity, y approaches positive infinity as well, and also as x approaches negative infinity, then we're continually heading down that way. So y is going to be approaching negative infinity because we go down on the other side. So here's our differential equation. Slope field given, complete the table by determining the slopes, if possible, in the slope fields. So at the point -4, so let's see, 1, 2, 3, 4, and then up 1, 1, 2. So about right here. Oh, that's a perfectly flat line. So that's going to be 0. And -2, let's see, 1, 2, and then up and down 0. Then it's kind of going up. It's pretty steep. So we could say something like 4. Or, what we could also do, because I'm clever, is we could just kind of like plug it into here. So that's 0. So -2 minus uh, oh, other way around. Other way around. 0 minus -2. So 0 minus -2. That is going to be +2. So then our slope there is 0. Did I get that other one right? I don't think I got that other one right. Because all we're trying to do is just kind of plug these values into this equation here. So if we did, let's see, our x value is -4. So it'll be plus 4 and then 2. So yeah, we should have gotten 6. I think I just miscounted my tick marks. It's tough to tell the tick marks aside from the whatchamacallit, slope field stuff. So, all right, x is 0, so 4 minus 0. I really wish these columns were the other way around. It'd be so easy to do. 4 minus 0, that's 4. 4 minus 2, oh, that's 2. 6 minus 4, oh, that's 2. And then 8 minus 8 is 0. And you can see that 8 minus 8 is 0 because we've got a horizontal tangent line at those points. Everybody else is just going to be like, they're slanty. So, but they're all going up, so they must be positive. And for the most part, that's what you're going to be looking for. If you make it yourself, you just plug in the numbers. If you're just trying to look at the graph, it's like, oh, it's going up. It's positive. I don't really care how positive it is. It's going up. And that's our quick review of slope fields. A reminder that if it is a horizontal tangent line, you want to make sure you've got that nice horizontal line. If you get something that's undefined, something that you can't do, then make a vertical line because that's kind of like a vertical tangent line, so our derivative won't work. If it's positive, just make it slant up. If it's negative, just make it slant down. Thanks for watching. Bye-bye.